Hydrograph. Hydrograph means it is a graph showing variations of discharge with time at a particular point of a stream. A graph which is showing variation of discharge with time at a particular point of a stream is known as hydrograph. You can see that the discharge versus time for a hydrograph, discharge versus time. And it consists of three segments, that is rising limb, peak or crest segment, and recession limb. These are the three components of a hydrograph. You can see AB is the rising limb, BPC is the crest segment, that is BPC is the crest segment, and CD is the recession limb. Then the hydrograph of a isolated storm will be a single peaked hydrograph. That is, here you can see it is a single peaked hydrograph, which means the hydrograph from a isolated storm. An isolated storm produces a single peaked hydrograph, while a series of storms, a series of rainfall, or a series of storms, it is also called as complex storm, produces multi-peaked hydrograph. That is, an isolated storm produces a single peaked hydrograph, while a series of consecutive storms, a series of consecutive rainfall, that is, it is called as complex storm, produces multi-peaked hydrograph. Then the components are rising limb, crest, and recession limb. The rising limb is shown by AB. The rising limb AB, you can see here AB, it is the ascending portion of the hydrograph. You can see AB is the ascending portion of the hydrograph, which shows an increase in discharge. Rising limb, that is represented by AB, it shows an ascending portion, that is ascending portion of hydrograph, then it shows or it depicts an increase in discharge. Then you can see point A, you can see here point A. Point A is a starting point, while point B is the point of inflection. That means the change point. The change point where the change of curvature occurs. Here you can see there is change in curvature from B. So B and C are called as point of inflection. They are the change points, that is the point where the curvature is changing. So point B and point C are called as point of inflection. Then you can see the portion BPC, that is the crest segment or the peak. It indicates a peak flow rate, that is a maximum flow rate. Then next is the recession limb, that is CD. It shows an decrease in discharge. It shows a decrease in discharge. Then you can see TP. TP is called as time to peak. It is the, you can see it is a time interval between A and P. That means it is the time interval between starting point of rising limb to the peak of hydrograph. Starting point of rising limb to the peak of hydrograph. That is what is called as TP. Between A and P. That means between the starting point of hydrograph and the peak. That is about the components of hydrograph. Next, we can see separation of base flow. You have learned about base flow in the previous class. You have learned about runoff, direct runoff, base flow, etc. in the previous class. So today we can learn about separation of base flow. Then, point A can be easily located. That is, you can see point A in the hydrograph. Point A in the hydrograph can be very easily located, but it is difficult to locate point D. Point A can be easily located, while point D, it is not too easy to locate point D. So, in order to locate point D, we have to find N. We have to find N, and N is given by two equation. N is equal to A into Tp, where Tp is the time to peak and A is a constant. For smaller basin, the value of A ranges between 2 to 4. And for larger basin, the value of A is 4 or above 4. Then the second equation, N is equal to 0.827 A raised to 0.2, where capital A is the area of drainage basin in kilometer square. So that we can find N and we can easily locate point D after finding N. So for separating base flow, we depend on two methods. One is straight line method and next is two lines method. The simplest method among them is straight line method. The most simplest method is straight line method. First we can talk about straight line method. Here you can see point A and point D. Point A marks the beginning of direct runoff. Point A is marking the beginning of direct runoff. And point D marks the end of direct runoff. You can see 2 points here. First, you locate point D after calculating N. Now you know there are 2 points A and D. A is the beginning of direct runoff and D is the end of direct runoff. We join those points A and D using a straight line. Using a straight line, we join point A and point D. You can see here, point A is joined to point D using a straight line. So, above the straight line AD, it is direct runoff, and below the straight line AD, it is base flow. That is, the line AD separates the base flow and direct runoff. The line AD is separating direct runoff and base flow. You can see the straight line AD. We join the starting point of direct runoff to the ending point. So we obtain a line AD. And above AD you can see there is direct runoff. And below that it will be base flow. So we can say the line AD separates or demarcates the direct runoff and base flow. That is about the straight line method. Next is two lines method. In case of two lines method, the curve is extended. The base flow curve is extended. That means from A, we are extending the line. From the point A, we extend the line. We extend the base flow curve. That means from point A, we extend the line. Similarly, we extend the line from point P, that is a perpendicular line from point P, that is from the peak is extended. You can see the point P. P means it is a peak. So from point P, we are drawing a perpendicular line. Similarly, we are extending the line from A So it meets at a point E. That is, we extend the base flow curve so that we obtain a line AE. Similarly, we draw a perpendicular line from point P. So both of that lines meet at point E. You can see those lines meet at point E, and from E you extend the line to meet point D. From E you extend the line to meet point D. So you can see that the segments AE and ED demarcates or separates direct runoff and base flow. That is, above the segment there will be direct runoff, and below that it is base flow. You just extend the base flow curve, so you obtain a line AE. Similarly, you draw a perpendicular line from point P, that is a peak point. Both of the lines meet at point E, and from E you extend the line so that it meets at point D. So we can say the segments AED separates direct runoff and base flow. That is about the separation of base flow using straight line method and two line method. Next is unit hydrograph. Unit hydrograph means it is a hydrograph which represents 1 centimeter of runoff. It represents 1 centimeter of runoff from a rainfall of some specified duration or unit duration. That is, you should remind, it represents 1 centimeter of runoff. As the name tells, unit hydrograph, that means it represents 1 centimeter of runoff. For example, a 3-hour unit hydrograph means it is a hydrograph produced by a runoff from a storm lasting for 3 hours, and it producing a runoff of 1 centimeter. A 3-hour unit hydrograph means the storm or the rainfall lasts for 3 hours, but the runoff is 1 centimeter. Similarly, a 6-hour unit hydrograph means the storm or the rainfall lasts for 6 hours, but the runoff or the rainfall excess is 1 centimeter. That is what is called as a unit hydrograph. In the next class, we can learn about the assumptions, some limitations, and uses of unit hydrograph. Okay? Thank you.